Good morning, everybody. I'm Julia Santagata from Ramsey Electric. Thank you for joining us this morning for today's every Tuesday webinar session. The topic we'll be covering today is the benefits of networking, of programming, being able to program all your networked HMIs from one location. So what can you do with networked HMIs, and why would you possibly consider that for your plant floor? So the presenters for today's call, we have three of our automation and software specialists presenting. Go ahead to the next slide, Mace. So three folks joining the call today are Mace Bittman, Steve Huck, and Ed Gallagher. All of these gentlemen cover automation from a PLC, HMI, software, and process perspective. So with that, I'll let them each do a quick introduction and we'll get going.
Okay, thank you, Julia. Yeah, as she said, my name is Mace Bittman. I've been with Rumsey a little over 7 years. PLC HMI software is primarily my studies. I've been doing this for a little over 20 years with automation controls in general, and I was at another distributor up north for over 10 years before that, as well as an OEM. So I've been on the OEM side of manufacturing.
I'm Steve Huck. I'm an automation specialist out of the South Jersey, Southern New Jersey territory. Been with Rumsey for about 12 years. Prior to that, with other Rockwell distributors for about 9 years. So prior to that, I worked for an OEM. So for about 24 years, been working with Rockwell Automation.
And good morning. My name is Ed Gallagher. I'm based out of the Lehigh Valley region, and I've been doing this longer than I care to remember. So about 40 years. That puts me at about the beginning of PLCs, and also 20 years as a distributor specialist, which again places me about when Logix first was born with Rockwell. So I've been there for both iterations.
Okay, well, great. So, guys. Oh, I'm sorry, good. So I'm going to start with some of the basics of HMIs, server-based, and probably some other products that you're used to seeing on the plant floor. So when you're talking about a manufacturing plant floor, there are many kinds of HMIs. The most common are firmware type, panel mounts. They usually have a dedicated function. They usually are one PLC, maybe a few. Then there's also panel PLCs. So in other words, an actual computer, typically a touchscreen. Some are touchscreens only as touchscreen monitors and a computer inside a cabinet. But the point is that they're not firmware based so much as a regular Windows operating system behind the scenes. Then there's also remote access that's become much, much more popular over the years, either using another computer somewhere and taking advantage of the web browsers, or a portable device, phone, tablet, iPad, such things like that. Circling back on just the first two panel mount styles, there is a machine edition style. They usually have one PLC connected to it, but sometimes you might have multiples, and that's certainly possible. Each HMI will have its own runtime file. So that particular file will have to be changed. If there's any changes to that file, you will have to edit it. Very often create the changed runtime file, take the unit out of service, restart it, and the operator would have to wait. And typically with any updates or changes to that firmware itself or the functionality of the panel view of the HMI, you will have to, again, interrupt and take the unit out of service, for instance, to load firmware and restart, similar types as with the runtime file. Now, PC-based ones, same things for its connections. You'll have one or more PLCs, not usually limited. It will have its own runtime file on the PC-based very often. And it has an independent runtime file of those other HMIs. However, most PC-based systems, if you have to do any changes to the runtime file, you can make edits, save them, similar to doing online PLC edits that you're probably used to now, And in most cases, restarting is not required. Additionally, if that HMI runtime has to add extra PLCs or database connections, again, the restarting is not usually required. So if we step back for a moment and just focus in on PC-based ones, there, as I mentioned, the standalone single runtime, but there is something called distributed or server-based. Let's look at the key points on those. Single station HMIs, as we say here, they require programming at each locations. So for example, if you had 10 HMIs, that is 10 HMIs, 10 locations to program. The PLC connections for each HMI will have to be modified at each HMI. And if you needed to add buttons or to add displays or anything like that, again, at each location, you would have to edit those. But it is still superior than the firmware-based type machine edition style, where you cannot without doing a restart type functionality. Now, server or distributed HMI style is a little bit different. You only have one location or one computer that you have to connect to change any of the HMIs or any of those display buttons, anything like that for all of the HMIs. In other words, instead of connecting to 10 different HMI locations, as this example, you go to one. This is also a single place for PLC connections. The server will connect to a PLC, and that is just one location where you have to change that. So all the other 10 HMIs can utilize that single connection. If you do online edits, again, you connect to the one server for any of the HMIs, and you can edit the screens, add buttons, and so on. Now, some distributed systems, as we're focusing on, can actually handle up to 80 remote HMIs. So that'd be one server where you can serve up to 8 distributed throughout your plant floor, networked appropriately to control and program all of those on the one server. A little more details on distributed. You can actually have redundant servers. So if you sit there and you're thinking, oh gosh, I don't want to have all my servers, as they say, eggs in one basket on one server, you could have multiple computers in a redundant fashion where they interchange all their information synchronized for, again, those 80 HMIs up to 10 servers. Same with one thing we haven't mentioned earlier about distributed is you can have many data connectors beyond just simply connecting to a PLC. The most common would be Microsoft SQL or OPC UA or DA. Those are very commonly needed to connect to maybe multiple manufacturers of database systems out there. Now, if you have a long system, maybe a long conveyor system, you might want the exact same HMI, 2 or more locations on that system. Well, you can actually just simply copy and paste or display the exact same screens in multiple locations. Furthermore, if you have a whole bunch of VFD drives or some other shared screen, that can be one display or many displays. Because it's at a server, it's very, very easy to deploy that. Then when you're talking about, again, the comparison between computers and panel mount or firmware-based, there's usually a very different quantity or increase in quantity in the tag count for this computer-based HMIs. And we'll provide some best practices with this presentation and along with the collateral. Now, really the best, in our opinion, software to do all this is something called Rockwell Automation's FactoryTalk View Site Edition. If you're familiar with Machine Edition, this is a computer-based called Site Edition. They say site, as they say, for the plant floor, it covers many areas in your plant instead of just the one-off standalones. As I said before, you can control up to 80 displays in one location. That gives you a lot of advantages, time savings, and benefits where you don't have to worry about running to different machines. Now SE has been out for many, many years. It's a very powerful software, runs VBA code and other things like that. So that makes a lot of migrations from other platforms or other HMIs very easy to migrate into a Site Edition server. For instance, if you have PAMV pluses, maybe you have 2, 3, or whatever on different systems, all you have to do is network them with some sort of quality Ethernet, and we're certainly able to help you do that. You could have all of those replaced and import all those projects into a Site Edition server. If you have any of the older RSV32 projects out there, same thing. You can migrate those into Site Edition, as well as we often get requested for other manufacturers, such as Wonderware or InTouch, to migrate that into our products. Now get into the specifications a little bit. How does all this work? Some of the deep dive details would be a long conversation, but FactoryTalk Services is one of the items that's running in the background, and that gives you health. It also helps you automatically cache and switch over from one server to another. You'll find that these clients, or as far as the operator is concerned, when it changes over, has little or no bump when it changes over. So if there's any kind of health in the PC, a network failure, whatever you might have, you'll find that the service for the operator is basically up all the time. The other advantages are visibility. It just takes care of all this, again, for any hardware or network failure. And there's nothing you have to do. There are selections in the software you initially set up, and it's all automatically going to do this replication and give you the standby server to flip up as the primary server. And if you have any doubts, there are ways to test it. Moving on with FactoryTalk View Site Edition features, this is just a quick snapshot of some of the feature sets. As I said, 80 clients, but I didn't mention the mobile clients yet, and you can have, with certain conditions, up to 100 of those. So you can have an awful lot of remote controlled or just view, depending on the security logons, from mobile devices such as your phone as you're walking around the plant. 750,000 tags at this point is one of the recommendations to stay under, as well as 100,000 alarms. Now, if you're probably sitting there and looking at this, you're thinking, goodness, I don't have half that. So I think you'll find that those specifications work well for you. And then as well as 10 HMI redundant servers are possible. Now, with that in mind, I just want to briefly show you what the software looks like. And if you've done FactoryTalk View Machine Edition, you might recognize some of these, but I'm just going to breeze through a few of these to give you an idea how easy it is to go from any other type of single standalone situation into one server-based setup. So I'm going to go through, start a new application. I'm going to create an area. I'm going to create an HMI server. I'm going to connect set up FactoryTalk links, and some of you may be watching that have heard of this or have heard of Links Enterprise. This is the new name for Links Enterprise. There's a server separately just for alarms and events for various reasons. There's also a way to connect to some of those other databases I was talking about. So I'm going to show you quickly where the selection would be to add an OPC server database connection in the software. I'll also just quickly show you how to start a display and where that is in the project tree. Then, as I said about replacing all these other single standalone PAMV pluses, some people like to have separate areas for each HMI. So let's say you have 10 different HMIs you want to import into View SE. You could have them actually be separate areas, completely different screens and all of that. So I'll give you that choice as well when I show you the software. That might be just some of the architecture you decide. So if you look at the software, have FactoryTalk View Site Edition launched. As you can see in the banner, it says Network Distributed. You click New Area. You give it a name. I just called it Area 1 in this example. You click OK. Now we have a new area. That area now you can build on. So I'm going to add an HMI server. In this case, I'm just going to say create, but as you can see, you can import other projects or attach to another HMI server. I just gave it a name, and this could be maybe your first on-machine firmware-based panel you want to start converting. It's just a possibility. Then you need to give it some connection device. As I said, FactoryTalk links. So this would be what you add on to connect to PLCs. I just left the name as it was. And this, for you Machine Edition people, would probably look very familiar. You had the FTVIEW links icon, and then you have the actual communication setup. That is the same place as Machine Edition where you would set up a shortcut. And the key is that shortcut will be the same throughout the HMI server setup. So that's why other screens can easily access that one connection instead of having all these other HMIs to worry about and program separately. So here's pretty much what we created. As you see, it just take a few seconds and a few minutes depending on the names. You have the area, you have the FTVIEW links connection, the HMI server, and then those are the displays that automatically get generated as soon as you tell it HMI server name. Then you want to set up an alarms and event server. I just gave it the same num. Notice the redundancy tab. You can have redundant on just about everything you can imagine in this architecture, including redundant servers for HMI, alarms and events. This is how you'd look, what it would look like if you wanted to add an OPC server to this particular HMI project. This is what it looked like if you want to start adding screens. Just underneath the graphics icon, you right click and say new. As you can see in the big blue arrow, that's what it looks like. And of course you save it and give it a name. I also like to always point out the pathway. If you notice, it says the application name and then the area. If you start having a lot of areas, a lot of different applications, it's nice to have that pathway to help you organize or know where you are and what screen you're editing. So to circle in what it looks like, there's the application name. But if you want to add a second area, as I was saying, if you want to separate all those 10 HMIs, you could easily come in here, right click, say new area to add a second area. The second area will simply show up below the first area. So as you can see, it has the same components. So I added an HMI server and links and all those things. It's exactly as the first piece as you saw to add through. And now you're just going to do your displays. You're just going to connect your FTVIEW links to your PLCs and begin programming. So it's nothing to be afraid of or daunted by. There are some labs that are pretty elaborate Rockwell has, which are wonderful, but I always like to show some of the basics here just to make sure that this stuff is not hard to program. All right, and with that, Steve Huck is going to help us learn more about ways you could actually use FTVIEW Site Edition as your mainframe and have other devices and other hardware connect to it.
Great, thank you, Mace. All right, I think we're there. Great. Now that Mace has explained the benefits of running a server client-based HMI system over a standalone HMI terminal, I'd like to talk about the next step on the journey, and that would be centralized management and thin clients. While modernizing to a distributed HMI system does indeed offer many benefits all on its own, utilizing thin client hardware can maximize the return on your investment by prolonging the life cycle of your plant floor HMI devices 2 to 3 times that of a standard thick client used in traditional distributed HMI deployments. What are thick clients? Well, simply put, thick clients are PCs running applications and software. For decades, manufacturers have relied on PCs to host the applications and content that drive their productivity. While PCs have served an important purpose, they've also become a source of excess time and expense to manage and maintain in a modern manufacturing environment. Each PC, or every PC, requires maintenance and upkeep of an operating system, user applications and antivirus, even hard drives, fans, and power supplies that eventually fail. Replacing a PC, even with a well-managed set of images, can require hours, resulting in costly downtime. PCs are also vulnerable to malicious attacks. Open USB ports, local hard drives, and user management challenges all create wide surface area of attack for anyone seeking to cause harm. Centrally managed thin clients can help modern manufacturers overcome these challenges. by allowing the replacement of PCs with more secure, easier to manage thin client terminals that have no hard drives or moving parts, and by default, block access to USB ports for anything except for a keyboard and a mouse. Thin clients, sometimes referred to as zero clients, also have no operating system and store no local data. This not only makes them more secure than PCs, but also makes them more reliable and easier to maintain. By centralizing all applications and processing to secure servers, manufacturers can reduce the amount of resources that have to be managed, and by replacing end user PCs with thin clients, maintenance and downtime are greatly reduced on the plant floor. If a thin client terminal does fail, it can be completely replaced by anyone in about 2 minutes with no loss of data. A centrally managed thin client architecture also greatly reduces the number of operating systems that need to be maintained, whether virtual or physical. The powerful, simplified deployment options offered also make it highly scalable. Applications installed once on servers can be deployed to many end users and end user terminals without any additional configuration. This content can be from your HMI servers, live video feeds from IP or USB-based cameras, work orders, PDF copies of standard operating procedures, information from your ERP or MES applications, nearly anything that can run on a Windows OS, be hosted by a web server, or accessed via remote desktop or VNC, including PanelView Plus and PanelView 5000 applications. All of this content can be combined and delivered to any thin client in the system. You can quickly add additional users, terminals, camera feeds, and more to expand your plant floor visualization and control. Finally, centralized content delivery and device management allows secure mobile content delivery designed specifically for industrial applications. Only deliver mobile content to specified locations that you configure using resolver technologies like GPS, Wi-Fi, Bluetooth, or QR codes. Set up predefined, secure areas where mobile content can be delivered, and more importantly, you can prevent delivery of mobile content outside of those authorized locations, no matter what level of access an end user might have. For more information on how to take advantage of centralized user and device management and content delivery when deploying secure industrial thin clients for your HMI systems, contact your Rumsey account manager or ASG specialist and ask about ThinManager. ThinManager can easily deliver all kinds of content that your workforce needs to do their jobs. Content like HMI, ERP, MES applications, USB or IP-based cameras, PanelView Plus, PanelView 5000 can also be delivered via VNC. You can see here, content can be just about anything that works in a Windows environment on the left side. Delivery of that content can go to devices, users, or locations. Those devices could be the thin clients that I've been talking about. They could be standard PCs running a thin client application or booted up in what they call Pixie mode. They can also be mobile devices, phones, iPads, other types of tablets. Thin client networks are already inherently more secure than traditional PCs, but ThinManager increases the security even further by employing powerful user authentication techniques and giving you the ability to designate specific locations for content to be delivered within the facility. Devices, as I said before, can be zero or thin clients. They can be mobile devices. They can be full-blown PCs, but each are managed exactly the same way within ThinManager. And that content that we talked about can be assigned and delivered in any combination by device, user, location. ThinManager also supports the new VERSAVIEW Thin Client series as ThinManager Ready Thin Clients. All of these units will automatically boot from ThinManager. All of these units are industrially grade and support more strenuous work environments. And all of these units should have a life cycle that is 2 to 3 times that of their PC counterparts. Simply put, ThinManager delivers the right content to the right person at the right place. And now I'll turn things over to Ed.
Thank you, Steve. Can you hear me?
Indeed.
Okay. So as Steve said, and Mace said, we're going to share a little bit with you on, actually at this point, this is going to be based on the deployment of the systems. Mace kind of went through a little bit of this. So again, factory talk view in a typical system is going to have multiple pieces and parts. So we have the HMI server that he discussed, the data server, alarm servers, we've got clients, factory talk directories included. So there's a lot of software components as part of this. And the beauty of factory talk view distributed is that these can get run or as we call it, distributed to allow for system loading. So what it looks like, if you look at the simplest application is we're going to take all of the components and load them on one server. And in this case, when we're referring to server, we're going to be either talking about a physical machine or a virtual machine. So those terms are kind of interchangeable depending on the infrastructure, although virtual machine is now becoming pretty much the standard of what we're going to use. So as you can see, the components we talked about, other than the clients, are basically loaded on one computer. Everything's loaded there, and the clients will again be loaded on separate computers, and those again can be thin clients or thick clients, as Steve discussed. And also we typically refer to the engineering workstation or the View Studio development that you want on a separate computer that you can do all the programming from. Now, this is suitable for small systems, smaller systems, 3, 5, maybe even up to 10 clients. If you're going to use a work group, that can be up to 10. But the big problem here, as you can see, as Mace discussed, is we've got a single point of failure. If that server goes down, all your HMIs are down. That's typically not a good thing. But perhaps you have a backup ready or something, or potentially that you can take into account and say, well, hey, if I'm down for HMI for a half hour, that's good enough. But in today's environment, that's usually not a good answer. So what we can do to help or to scale up the larger systems is we can now take all those components we discussed and load them on separate servers or images, as we call them. So now you're splitting that out, and this will scale up to what would account for larger systems. As Mace went through, we can do 750,000 tags, 100,000 alarms, 80 clients, up to 20 servers, or 10 redundant pairs. Now, obviously, that's a very large system, and you're not going to run that on one computer. So that's going to take many, many computers or many, many images to scale up to that. But in this case, as you'll see, we still have single points of failure. If our SE server went down or image went down in this case, you're still not going to have, part of your system working. So that lends itself to what he also discussed, which was high availability. We're going to take all the components and we're going to duplicate them and run them on redundant servers. So again, we can scale this up to a very large system, and we have no single points of failure. If any of the servers or anything happens, we're going to fail over and go to the backup. This is a very good, very robust system, but as you can see, this can easily get up to include a lot of hardware, a lot of images, a lot of complexity. So as you can see, this greatly increases hardware cost, which would translate to virtual images as well, as where they're going to be hosted. The other thing we're looking at is typically to host that much stuff is you're typically back at maybe your plant's data center. Or, in the case of you've got all the servers in a room and they're separated from the plant floor, potentially it's a cloud. Again, as we look at the virtual images, those are typically either a private or public cloud where you'd be running all these. So again, those are kind of removed from the plant floor. So in the case of an HMI problem, other than replacing the physical device on the plant floor, either the computer or the thin client, there's not much else troubleshooting you can do with the plant floor. So typically you got to get IT involved or some other level. And if you don't have failover, or if you have a catastrophic failure, this can be very time consuming. So a new trend that's emerging now is, and you may have heard the term edge or edge computing, is, well, we may take some of that capability and bring it down closer to the plant floor. That makes less dependence on network infrastructure and makes troubleshooting a little easier because it's closer to where you need to do. Now, one of the challenges there on these typical distributed systems is they're highly involved, a lot of pieces and parts involved, and computers. So typically at the OT or the plant floor level is you may or may not have that level of expertise in place. So that could become cumbersome on how you manage this. So there is a better way. And what we're going to discuss is a fairly new solution in the arena. And this allows for taking what we've been talking about, a highly distributed system, highly fault tolerant system, and bring it out to the edge. So if you had a simple single computer setup like we discussed, rather than multiples, it was easy to deploy in a virtualized environment, no touch, high availability, plant floor panel installation, OT level maintenance, and simple selection. That would kind of meet the best of both worlds for taking a highly complex solution, yet making it manageable on the plant floor. Well, there is one now, and that's what we're going to talk about a little bit. It's called the ZTC Edge. So this is a new level of computers that are available now. And as you see, unlike industrial computers, it has built-in virtualization and availability. So what that means is where we sold the distributed components before, now you have the ability to run those on multiple images. And because it's built in and easy to configure, you reduce the complexity. Nobody needs to understand VMware or something highly complex. And unlike industry standard servers, is rugged and can be deployed on the plant floor. So now we took what would have been typically back in an IT infrastructure, and we can basically put it out on the plant floor. And unlike a high availability or redundant server cluster, it's easier to deploy, operate, maintain because of its highly virtualized computing infrastructure. So it makes things a lot simpler. And this is it in a nutshell. There's two versions. It's secure. It has the built-in virtualization, simplified security. It's industrial, OT manageable, and we can add redundancy to it. And there's also available service with Stratus that basically this can be connected to the web and it can alert them of any type of problem. And actually they can send out spares or replacements. So this basically takes what we were talking about and brings it out to the plant floor. As you can see, the ratings on it are very robust, -40 to +60 degrees. The humidity, the vibration. So this is a compact fanless wall or DIN rail mount, very small unit. So what would have typically been multiple servers in a data center is now a simple, easy to mount box that you can put out on the plant floor. And as you can see, one of the examples is this is built in. So this is just a typical showing that this has 4 VMs. These can typically run from 3 to 5 or 6 VM images, depending on what needs to be deployed. Configured with a simple console or web browser. So again, it's easy. You can import images, OVF images, of which Rockwell has some for our Plant PX system. So those are predefined. So basically within about a half hour, you can have one of these units up and running. So that drastically saves you time and money and also complexity. It doesn't need to be a highly IT specialized function. And this is an example of what we were talking about before, where we have a SCADA running. Remote desktop services would host ThinManager. As you see, we can also add alarm notification. As MACE said, we can have Microsoft SQL on for databases. Any number of things can be run on units. Beauty is you can scale these up. So in this case, if you have 3 to 5 images running on one, you can add another computer and basically double your capacity. And this gives you a little bit of an idea on ease of deployment. So as we look at the edge solution, 30-minute, no IT setup, and there's really no required maintenance because it's a complete solid state, no fans, no rotating hard drive. So basically there's nothing you need to do, very reliable. And because of that, recouping the initial investment cost is fairly quick on this because you don't have maintenance. You can go to standalone computers and spares. Again, typically not high cost, but it may take you, as we found, maybe up to 4 hours to replace one, because typically as time goes on, if changes have been made, they may not be replicated. You may need to load software, may need to load patches. So typically that's not a good idea for backup. And then we go all the way up to the highly clustered IT-centric solution. And that's been our traditional method of deploying larger systems. And it still is a viable option. This may be part of it. If the system's large enough, it may justify that type of infrastructure, and that's fine. And if your network can accommodate it, then that is a very good option also. But this is what it is in a nutshell. And as you can see, you can take either a single unit. There's 2 models available at this point, a 100 and 110. And they can be made either high availability or fault tolerant. Basically the same thing, other than the high availability typically is going to take a little bit longer to fail over. If it detects a problem, it brings the other images up, gets them up and running, and typically within maybe about 20 seconds or so, you'd be back up and running, which for an HMI is not a long time, and usually you can tolerate that. The fault tolerant is basically almost an instant switchover. So as you can see, these 2 units, you don't need to do anything to configure them. There's a pair of network cables, 10 gigabit, that connect between the units, and they basically synchronize themselves. So there's nothing you need to do to turn these other than add the second node and connect them up and configure it to run. And these are the specifications for those 2 units. And in general terms, each unit is a fixed price, and you buy the second unit. So basically it doubles, but we're in for a high-end 110 fault tolerant, you're at around a $15,000 level. So for multiple servers, easy to deploy, it's a very reasonably priced solution, and it basically gives you a easy to deploy on the plant floor. And that wraps that part up. So now we're just going to review a little bit of what we talked about. I think Mace will lead us off.
Great, Ed. That was well done. Thanks very much, and you too, Steve. Yeah, just in closing, if I had to sum up what my point was on my first portion, ability to program all your HMIs one location as well as single place to connect all your PLCs. That's definitely one major aspect of that. And then also to do online edits to all the HMI screens, whether you're adding a button, adding a whole display, again, one place. And if you want to add databases such as SQL or OPCs, you can do it with this system, but it's also like online edits. You can do it hot and click save, and off you go without taking anything out of the operators.
Again, coming back to ThinManager and Thin clients, if you're moving your way up to a server-based HMI system, embracing Thin clients and ThinManager as an infrastructure can have some great benefits. Probably top one, we're talking about secure plant floor hardware, no moving parts, no operating system, no access to USB ports. So very preferable over standard computers. Ease of replacement. We're talking, take it out of the box, power it up, couple of seconds, you're back up, you've lost no data. The ability to deliver content, lots of content, various different sources of content, combine them together, share them, and deliver them in any combination of device, user, or location, as well as having those secure mobile options. ThinManager and Thin clients really bring that to the table for us. And the last thing here, I don't think I stressed as well, wizard-driven. ThinManager is designed for OT, not for IT. This is something for someone that's used to working on the plant floor to be able to configure and maintain, as opposed to having to have IT involved.
And to sum up what we talked about, if we're going to move to this server-based HMI, considering the industrial edge servers, you get rugged design intended for the plant floor and stable, and with built-in virtualization and availability, minimal maintenance or support skills needed. So a lot of the same reasons you're going to use Thin clients. The new edge server class machines make life easy. It's almost turning into a plug and play now, what used to be a very highly complex endeavor. So with that, we'll wrap up. And I guess if there are any questions, anybody has anything?
I don't think we have any questions at this time, Ed, so we can wrap up. Thank you very much, Ed, Steve, and Mace. I appreciate you going through the different aspects of what you can do with networked HMIs and using a server-based system. As a reminder to everybody, this is just one of an ongoing webinar series. They are being done every Tuesday at the same time, 11:30 Eastern, by one or more members of our Rumsey specialist team. So there'll be a link right there for the full webinar schedule, or you can go to rumsey.com and hit training to get an update of all the webinars that are coming your way. With that, thank you very much. Everybody have a great day.